A signal from deep space, a planet that defies all expectations, and a race to another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has uncovered secrets so shocking that they could rewrite the rules of life itself. But is Proxima B truly a new Earth or a deadly trap in the vastness of space? The James Webb Space Telescope, often hailed as humanity's most advanced instrument in the sky, has recently turned its gaze toward one of the most intriguing exoplanets ever discovered. Proxima B, this distant world orbiting the red dwarf star Proxima Centauri, has captivated scientists and enthusiasts alike since its discovery. But now, with the unparalleled capabilities of the JWST, we are finally getting a closer look at this mysterious planet, and the revelations are nothing short of extraordinary. Proxima B was first detected in 2013, but it wasn't until the James Webb Space Telescope came into the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing details that were previously hidden from view. What they found has sparked both excitement and concern. Proxima B orbits its star at an incredibly close distance, just 7.3 million km away, which is less than 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11.2 Earth days. But what makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf, unlike our Sun, which is a relatively stable star. Red dwarfs are known for their volatile nature, often emitting powerful solar flares that can drastically affect the planets orbiting them. Now here's where things get even more interesting. The JWST has provided the clearest view yet of Proxima B, and it's revealed some startling features. For one, the planet is about 30% more massive than Earth, which means it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked with its star. This means that one side of the planet is in perpetual daylight, while the other is shrouded in eternal darkness. Imagine the kind of world where the sun never sets on one side and the other is plunged into an endless night. This tidal locking creates a harsh environment for any potential life forms. The side facing the star would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question: could life ever survive in such extreme conditions? The possibility seems slim, but nature has a way of surprising us. But the challenges don't stop there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. The JWST has revealed that the star is far more active than previously thought. Its powerful magnetic fields produce intense solar flares that bombard Proxima B with high energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that proximity to star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way to adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such a volatile environment, or is the planet doomed to remain a barren rock devoid of life? As we continue to explore Proxima B with the James Webb Space Telescope, more secrets are sure to be uncovered. But one thing is clear: this tiny planet, just 4.24 light years away from us, is far more complex and enigmatic than we ever imagined. Could it be that Proxima beholds the key to understanding the limits of life in the universe, And if so, what does that mean for our search for extraterrestrial life Proxima Bs? Stunning secrets revealed. One of the most shocking discoveries was the planet's atmosphere, or rather the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B is constantly bombarded with solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some protection from the star's radiation. The James Webb Space Telescope has given us the clearest glimpse yet of Proxima B's surface, and what it has revealed is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth's, but with significant differences. For instance, the side of the planet facing Proxima Centauri is likely scorched by constant heat, creating a barren, desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland with temperatures plummeting to levels far colder than anything experienced on Earth. But the most intriguing possibility lies in the narrow strip of land between these two extremes known as the Twilight Zone. This area where day meets night might offer more temperate conditions where liquid water could exist. The existence of liquid water is, of course, one of the key ingredients for life as we know it. Could this Twilight Zone harbor a hidden oasis where life has managed to take root despite the harsh conditions on the rest of the planet? Another stunning revelation came when scientists examined the possibility of water on Proxima B. If water exists on the planet, it would likely be in the form of ice on the dark side or small, possibly temporary bodies of liquid water in the Twilight Zone. But the discovery that shocked many was the potential for subsurface oceans similar to those found on moons like Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core or by tidal forces caused by a B's close orbit to its star. If such oceans do exist, they would be a prime location to search for life hidden beneath the planet's icy surface. But let's not forget the potential challenges. The magnetic field of Proxima Centauri is another factor that adds complexity to the planet's environment. Recent studies suggest that the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction might protect the planet's atmosphere from being completely stripped away by solar wind, much like Earth's magnetic field protects us from the sun's radiation. However, the situation on Proxima B is far from straightforward. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and sudden changes in the planet's climate and surface conditions. These discoveries raise more questions than answers. Does Proxima B have a magnetic field? How strong is it, and how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive the planet's harsh and fluctuating conditions? And if life does exist, what form would it take? Would it be something entirely different from anything we've seen on Earth, or could it share similarities with extremophiles that thrive in Earth's most inhospitable environments, a hostile world where life faces extreme challenges? While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality is far from hospitable. The James Webb Space Telescope has provided unprecedented insight into the challenges any potential life on Proxima B would face, and the picture is anything but rosy. One of the most significant challenges is the planet's exposure to extreme levels of radiation from Proxima Centauri. Unlike our sun, Proxima Centauri is a red dwarf star with a much smaller mass and a much more chaotic surface than stars. Proximity to Proxima B means that the planet is constantly bombarded with intense solar radiation, including powerful flares that can be 100 times stronger than those emitted by our sun. These flares produce a deadly cocktail of ultraviolet and X-ray radiation that would be lethal to any life form similar to those on Earth. The effects of this radiation are not just theoretical. In April 2021, a particularly massive flare from Proxima Centauri was detected, and it was strong enough to potentially strip away any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed by red dwarf stars and casts doubt on the likelihood of Proxima B being a haven for life. Moreover, the constant exposure to such radiation would make the surface of Proxima B an incredibly hostile environment. Any water on the surface would be rapidly vaporized, and the planet's rocky landscape would be scorched by the relentless heat. The dark side of the planet, while not exposed to direct radiation, would be equally inhospitable due to freezing temperatures. This extreme dichotomy between the scorching day side and the freezing night side leaves little room for a stable life sustaining environment. The race to reach Proxima Centauri begins while the signal from Proxima Centauri remains a mystery. The idea of actually reaching the star system has moved from the realm of science fiction to a genuine scientific endeavor. The Breakthrough Starshot initiative, spearheaded by a team of visionary scientists and backed by prominent figures like Stephen Hawking and Yuri Milner, aims to send tiny laser-propelled spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The concept behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp, into space. These star chips would be propelled by powerful lasers, allowing them to travel at up to 15 to 20% of the speed of light. If successful, they could reach Proxima Centauri in just over 20 years, a mere BL link of an eye in cosmic terms. However, this ambitious plan still faces numerous obstacles, not the least of which is the development of the technology needed to propel the spacecraft at such incredible speeds. Even if Breakthrough Starshot succeeds in its mission, it would take several decades for the information to return to Earth. In the end, Proxima B remains a tantalizing mystery, its future uncertain. Whether it harbors life or is simply a barren rock, the planet's story has only just begun. As the James Webb Space Telescope continues to explore the far reaches of the universe, we can only hope that more answers and perhaps even more mysteries await us in the vast expanse of space. The search for life beyond Earth is one of the most profound questions humanity can ask. While Proxima B may seem like a prime candidate for extraterrestrial life, its hostile environment raises many doubts, but this hasn't stopped scientists from pursuing answers. Proxima B is just one of many planets being investigated by astronomers with a focus on those located within the habitable zone of their stars. This zone, often referred to as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist. Water, as we know, is essential for life, and it's no surprise that much of the search for life revolves around planets that might harbor it. One of the most important tasks of the James Webb Space Telescope in the coming years will be to study more planets like Proxima B. By examining their atmospheres, scientists can look for signs of chemicals associated with biological processes such as oxygen, methane, or carbon dioxide in particular ratios. However, finding these biomarkers doesn't necessarily mean we found life. There are many natural processes on planets that could produce similar chemical signatures, so the task is far from simple, and in the case of Proxima B, the intense radiation and volatile conditions make it even harder to draw definitive conclusions. But despite these challenges, the search for life is far from hopeless. Even on Earth, life thrives in extreme conditions that were once thought inhospitable, such as in deep sea, hydrothermal vents, acidic lakes, or frozen tundras. Life forms known as extremophiles have adapted to survive in some of the harshest environments on our own planet. Could similar organisms exist on Proxima B or another world with comparable extremes? This question remains a tantalizing possibility that drives the scientific community forward in its quest to explore the unknown. While Proxima B may be one of the most studied exoplanets, it is far from the only one. In recent years, astronomers have identified thousands of exoplanets, some of which appear to be Earth-like. A particularly exciting discovery has been the detection of planets within the habitable zone of stars similar to our Sun. These planets are located at the right distance from their stars to support liquid water, and some even show promising signs of having atmospheres that could support life. One of the most exciting discoveries came with the discovery of the TRAPPIST-1 system, a collection of 7 Earth-sized planets orbiting a star just 39 light-years away. 3 of these planets are located in the habitable zone, and researchers are eager to study them further with the James Webb Space Telescope. If life exists on any of these planets, it would provide new insights into the nature of life beyond Earth, and perhaps even answer some of the biggest questions humanity has ever asked. Another planet on the radar is Kepler 452b, often referred to as Earth's cousin. This exoplanet is roughly the same size as Earth and orbits a star similar to the Sun. While scientists are still studying the planet to determine if it has the right conditions for life, the discovery has sparked excitement about the potential for finding another Earth-like world. Though Kepler 452b is far from Proxima B, its existence serves as a reminder of the vast number of planets out there, each with its own unique characteristics and potential for discovery. As technology continues to advance, our ability to explore distant worlds and understand their potential for life will only improve. The James Webb Space Telescope has already begun revolutionizing our understanding of exoplanets, and it will continue to do so for many years to come. But it's not just the JWST that holds promise for the future of space exploration. Other upcoming missions like NASA's Nancy Grace Roman Space Telescope and the European Space Agency's Ariel mission will help us investigate the atmospheres of exoplanets in even more detail.